This activity is called It's a Toss-Up, or Toss-Up for short. This shows how a virus spreads through a simple community where people are not moving but have neighbors. For this activity, you'll need the lesson plan and a data sheet, some colored markers, and one die. I recommend having groups of students as that'll make it more enjoyable. So in this activity there are several variables. The first is transmission rate, and that's the proportion of people exposed to an infectious agent who become infected by it. So every time you meet someone and you're sick, you don't pass it to everyone you meet necessarily. The second variable is the duration, the amount of time the agent remains sick. And finally, the third variable is the virulence. That is how much this virus is able to spread. This activity can be used instead of the PDA virus game if you are unable to attain the PDAs themselves. For this game, we have the duration set at 1, and that means that an infected person stays sick for 1 round. We have 8 neighbors around each spot, and that can be seen in this diagram. Each agent has 8 neighbors around it. And finally, there's a transmission rate, and that can either be 16%, 33%, 50%, 66%, 83%, or 100%. Each group will choose a different transmission rate. So let's say my group chooses a 50% transmission rate, and we want to start with this person sick. So I'll mark it right there. Now what we'll do is we'll go around to each of that person's neighbors and determine whether they get sick or not. Also, we want to track at each cycle how many people are susceptible, infected, and recovered. So we start out with everyone susceptible, no one infected, and no one recovered. But as soon as we put down that first sick person, now we have 1 person infected, 0 recovered. That leaves us with 99 susceptible. And we might want to mark that this round was the red. So let's go around and find out who gets sick. First, I'm going to make a little dot at all the locations we're going to test. So let's start with this one. 1. We know 50% of the time a person gets sick. So I'm going to say I get sick if I roll a 1, 2, or a 3. So this person gets sick, and I can say that this agent spread it to that person. Next, this person gets sick too. That one doesn't. That one doesn't. That one does. That one does. That one doesn't. And finally, that one does. So we might want to put the green over here. And now, our initially sick person has now recovered because it's been 1 round. So recovered equals 1. Newly infected, 1, 2, 3, 4, 5. So 5 and 1 is 6. Remaining susceptible equals 100 minus 6, or 94. Let's do the next round in blue. Let's look at who can be infected now. These are all the potential people who could get infected by one of these agents, because each of the agents has an 8 by 8 around it. The one who initially was sick is now immune, so we don't have to mark that one blue. Again, let's start at the top and work our way around through all the susceptible people and see if they get sick. We'll start here. That person got sick. That person got sick. That person didn't get sick. That person didn't get sick. We're over here. That person didn't get sick. That person didn't get sick. That person didn't get sick. That person got sick. That person got sick. That person got sick. That person didn't get sick. That person didn't get sick. That person got sick. And that person got sick. Nope. That person got sick. And that person got sick. Okay, let's see what we have now. I want to mark this blue. And actually, there are some spots, like this spot, where this person could have gotten him sick, or this one could have gotten this person sick. If we wanted to be totally realistic, we would, for this sick person, go all the way around, as well as for this person, all the way around. So actually, we'd roll the dice twice for that one if we wanted to be totally correct. How many recovered now? all the green and all the red. So that's 1, 2, 3, 4, 5, 6. How many are newly infected? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many are susceptible? So we have 15 out of the pool, so this must be 85. Now I'm just going to continue playing. So here's our data, put down our graph. Let's do the number susceptible. And we're going to do those in green. We start at 100, with cycle 0, we called it 100. Cycle 2 went down to 99. Cycle 3, it went down to 94. You can sort of see what's going on. It sort of goes like this. Next, we'll do the infected, and finally the recovered. And there we have it. That's our SIR epidemic.